Okay, so in today's video, we have the given equation. The derivative of P over L is equal to dP over dL. And our question is, we're being asked is, what are the functions P and L such that it satisfies the following given equation? So let's get started. So left-hand side is the derivative of P over L, so I can actually just write the full derivative as like so. So d over dx divided by P, or of P divided by L, is equal to L dP dx, then minus P dL dx, and then divided by L squared. And then dP over dL, I'm gonna rewrite the right hand side so that we have dx's. So dP or dL is equal to dP dx divided by dL dx. Okay, so now we have these two rewritten. We can actually substitute it for our given equation. So that means we have the following: L dP dL minus P dL dP or dx. That's supposed to be an x. Dx right over here. Okay, and then divided by L squared. Then set that equal to dP over dx, and then divided by dL dx. Okay. So now, in order to find these functions, what I'm actually going to do is I'm actually going to set the numerator from the left-hand side equal to the numerator on the right-hand side, and then set the denominator of the left-hand side equal to the denominator on the right-hand side, so we get our two equations. This means we have the following: L dP over dx minus P dL over dx equals dP over dx, and then L squared equals dL dx. Okay, great. So let's actually solve the bottom equation first. This is actually this is a form of a separable equation. So I'm actually going to multiply dx to both sides, and we're actually trying to solve for the function L, as you can see. So that means, and then divide by L squared to both sides. So we have dx equals dL divided by L squared. Then we can integrate both sides. So we're solving for the function we're solving for the function L, so that means this is equal to x plus some constant b, and that's equal to -1 divided by L. But I can actually multiply the L to both sides, so that, and then divide x plus b. So that means we get, put it this way. So we get that L of x is equal to -1 divided by x plus b. Okay, I'm gonna circle that function. So we found one of our functions. So we found our function L. So now the last thing to do is to find our function P. So this means we have to, given that we have solved for our function L, so we can find the function P. So this means we're solving the top equation now. And I'm actually going to solve the top part with my purple marker instead. Okay. So our top equation, L multiplied by dP divided by dx minus P times dL dx equals dP dx. What I'm actually going to do is I'm actually going to subtract dP dx and then add P times dL over dx to the other side. So that means we have L, then dP dx, and then what did I say, minus dP dx, and that's equal to P times dL dx. And I can actually factor out dP dx. So this can be rewritten as parentheses L minus 1 multiplied by dP dx, and then equal to P dL dx. Okay, and now we can actually do some substitutions. So we have that L is equal to -1 over x plus b, so we can substitute L for that. And then we have a dL dx, but we have that dL dx is equal to L squared, so we found that L, so we're taking this function square. So when we do that, we get, write this in parentheses, we have that our L is -1 divided by x plus b, then minus 1 dp dx. Okay, and then we have p multiplied by dl dx. Well, dl dx is equal to L squared, so we take our L squared that, so -1, so that's squared, so that's +1, and then the denominator is x plus b squared, and then multiply that by p, so we have p divided by x plus b squared. Okay, nice. And now let's actually rewrite the inside expression here, so that way we have common denominator. Okay, so, and I'm actually going to factor out the negative, so let me rewrite this again a second time. So this is negative, then 1 plus x plus b, so factor out the negative, so this is a +1, dp dx equal to p divided by x plus b squared. Okay, nice. So 1 over x plus b plus 1. Let's get a common denominator. So we have x plus b and then plus x plus b. So this is 1 and then 1, by the way, that 1 plus b. So in other words, this is equal to x plus 1 plus b divided by x plus b. Okay. Okay, so now that we have the following, so negative x plus 1 plus b divided by x plus b multiplied by dp dx equal to p divided by x plus b squared. And then I'm actually going to divide p from both sides. So we have all the p's, and then we'll have p's, the p's on one side and then the x's on the other side. So when we divide this, flip the reciprocal, and then one of the terms cancel out from the numerator. So that means, okay, so that means we have dp equals p, then equal to -1 divided by x plus 1 plus b, then times x plus b dx. Okay. And now before we do any integration, this is also another separable equation we could do. Let's actually break this up, since this is a, we can split this into partial fractions. So that means we have, let's actually exclude the negative for just a second, and then we have, so we have x plus 1 plus b times x plus b. Okay, and we're set that equal to some unknown constant divided by x plus 1 plus b, then plus d times x plus b. Okay, so now we just have to solve our constants. I'm going to do the scratch work over here. I can actually just multiply c times x plus b and then d times x plus 1 plus b, and then set that equal to 1. So c x plus b, then plus d x plus 1 plus b equals 1. Okay, so let's actually first solve for our constant d. So in this case, we're going to let x plus b equals 0. So when we do that, when we substitute, so we get c times 0 is 0, and then x plus b, 0 plus 1, so it's d. So we have that d is equal to 1. Okay. So now let's actually set x plus b equal to -1. So when we do that, x plus b is -1 plus 1, this is 0, and then this is negative c is equal to 1, so divide -1 to both sides, so we get that c is equal to -1. Okay, cool. So now we have that. This is -1 -1 x plus 1 plus b, then plus 1 divided by x plus b. Okay, so, and then we multiply the negative, so then we have the following: dp over p is equal to what did I say? 1 divided by x plus 1 plus b, then minus 1 over x plus b. Okay. And now we have, with that, now we can actually take the integral of both sides. With respect to dx. So simply 1 over p, so that's just ln of p, and then equal to 1 divided by det, so that's ln of x plus 1 plus b, then minus ln of x plus b. Okay, and then plus for some constant a in this case. So now what I can use natural logs to combine, so this could be written as the natural log of x plus 1 plus b divided by x plus b, then plus a, and then I can take the base e on both sides, so we get e ln of p equals e ln of x plus 1 plus b divided by x plus b plus a, and then we get p of x is equal to some constant a. Since e to the a is some arbitrary constant, and e to the a is we can just call that a, and then cancel. So that means this is multiplied by x plus 1 plus b divided by x plus b. And then we can also rewrite this as p of x equals, since we have that, where is it? X plus 1 plus b divided by x plus b is the same thing as 1 over x plus b plus 1. So when we distribute the a, so we get a divided by x plus b, and then plus a. Cool. And then we're going to circle that. So therefore, we have the following. Therefore, we have p of x is equal to a divided by x plus b plus a, and L of x is equal to -1 divided by x plus b, such that for some a and b that are real numbers. Sweet. So we'll go to that one more time. Awesome. It's pretty sweet.